Welcome back, everybody, for another deep dive. This time, we're going to be looking at something that's been in the news a lot lately. AI cheating.
Yeah.
Specifically, how to spot AI trickery on multiple choice tests.
Right. Yeah, with AI being able to mimic human thinking, it's making us ask some pretty big questions about how we even assess knowledge in the first place.
Exactly. Our source material today is a paper called Applying Item Response Theory to Distinguish Between Human and Generative AI Responses to Multiple Choice Assessments. It's a mouthful.
Yeah.
But we're going to unpack it, uncover those key insights.
Yeah, and I think at the heart of it, this paper is looking at this growing concern around AI like ChatGPT being used to cheat.
Right.
Just imagine students using AI to answer all those multiple choice questions.
Yeah.
It really makes you question, how can we trust those grades and qualifications anymore?
You mentioned ChatGPT, and it's funny because it just takes me right back to taking the SATs.
Oh, yeah.
I mean, the pressure was intense.
It is.
I can only imagine how tempting it would be to use AI for a little extra help. But how do we even begin to untangle this?
Well, the researchers, they turned to a statistical tool called item response theory, or IRT.
Okay.
You can almost think of it like a detective using forensic evidence.
Ooh, I like that. So how does IRT help us catch these AI cheaters?
So basically, IRT looks at test results, and it tries to find these unusual patterns that kind of deviate from how a typical human would answer the questions.
So it's not just about getting the answers right or wrong?
No, it's about the patterns, the overall pattern of responses.
Okay. So IRT can tell if someone is just randomly guessing on a test or if they're maybe using an AI to feed them the answer.
Exactly. It can spot these inconsistencies that just wouldn't make sense for a normal human test taker.
So if a student aced a really hard question but then totally missed a bunch of easy ones, that would be a red flag.
That's exactly right. That kind of pattern might suggest that something's a little fishy.
So did they give ChatGPT a number 2 pencil and a Scantron sheet? How did they actually test this?
Not quite. So they had these three popular AI chatbots, ChatGPT, Gemini, and Claude, and they had them take these real high school chemistry and college entrance exams. So imagine a classroom full of AI students,
Whoa.
each taking the test 20 times.
They put these AI bots through the ringer. So what happened? Did the AIs just totally cheat and ace the test?
Well, initially, the chatbots did surprisingly well. And what's really interesting is they each scored differently, which
Ah.
suggests they weren't all using the same cheat sheet, so to speak.
Hold on. So each AI had its own unique way of answering the questions.
Yeah.
That's a little creepy, isn't it?
It is a little bit. It suggests that different AI models actually might approach problem solving in these very distinct ways. And that makes detecting this AI cheating even more challenging.
So it's not just a parrot spitting back information, it's actually thinking in a way.
It really makes you think.
This is getting deep. But ultimately, did they catch these AI cheaters?
Well, to do that, they use something called person fit statistics, or PFS. And this tool really digs deep into those AI answers. It looks for these red flags, like these statistically improbable patterns of correct and incorrect answers.
So PFS is like a lie detector test, but for tests.
Exactly. So instead of measuring, heart rate and sweating, it's analyzing those answer patterns.
So is it looking for inconsistencies that just don't add up for a normal human?
Exactly.
I'm on the edge of my seat. Did this PFS expose the bots?
Well, that's where things get even more interesting. And to explore that, we're going to have to continue this in the next part of our deep dive.
So we've got these AI bots taking tests and this PFS thing that's like a lie detector for cheaters. What happened? Did they get busted?
Well, it's not really a busted or not busted situation. Remember, each AI model kind of has its own way of approaching those questions. And what's really interesting is that the PFS scores weren't just random. They showed these patterns. Some AIs were better at certain types of questions and others struggled.
So it's like those personality quizzes, are you a ChatGPT or a Claude? But instead of telling you what pizza topping you are, it tells you how the AI thinks about chemistry or math.
Exactly. And that makes it tough because if each AI has its own unique fingerprint, you can't just make one rule to catch them all.
It's like trying to catch a gang of criminals, but each member has their own MO. But let's back up a sec. You mentioned these person fit statistics, PFS. How do they actually work? I get that they're looking for these suspicious patterns, but what's going on under the hood?
Okay, so let's take one of the PFS measures as an example. It's called the G statistic.
Yeah.
Imagine a test with questions arranged from easy to hard.
Okay.
A typical student, they probably ace those easy ones and then start making more mistakes as the questions get tougher.
Yeah, totally. We've all been there, hitting that wall where your brain just fries.
Exactly.
Yeah.
And that expected pattern of responses is what those IRT models are built on.
Hmm.
So the G statistic, it basically counts how many times a student's answer deviates from that expected pattern.
Gotcha. So if I nail a super hard question, but then blank on an easy one, my G-score goes up. Like, hold on. That's not how a normal human brain works.
You got it. It's about spotting these inconsistencies that seem out of place.
Yeah.
And then there's another measure called G-star, which kind of normalizes that G-score on a scale from 0 to 1. Think of it like a warning light.
Uh-huh.
The higher the G-star score, the more suspicious that response pattern.
Okay, so high G-star means, whoa, something's fishy here. This might not be a human.
Exactly.
You said there were other PFS measures, right?
Yeah. And they get even more complex. For example, U3 and ZU3, considering the difficulty of the questions and how they relate to each other. They use these statistical calculations to determine if a student's answers are like way off from what you'd expect based on the overall difficulty of the test.
So it's not just about individual questions. It's about looking at the whole test and seeing if anything stands out as statistically weird.
Right. It's like noticing that a student is consistently getting certain types of questions wrong, even though they're acing other parts of the test.
Okay, so this PFS toolset is starting to sound pretty powerful. But you mentioned earlier that the researchers also looked at what happens when you have different numbers of AI students mixed in with real students, right?
Yes, exactly. And this is where things get really interesting and potentially problematic. They introduced this concept of pollution, which is the percentage of AI-generated responses in the data set.
Pollution.
Yeah.
Like the air is filled with these tiny robot brains spewing out test answers?
Not quite. Imagine a classroom where like 10% of the students are secretly AI bots taking the test.
Okay.
There's 10% pollution in the data.
Sneaky bots. So how did those PFS measures hold up when they were faced with these different levels of AI infiltration? Could they still spot the cheaters?
So at those lower levels of pollution, like 5% or 10%,
Yeah.
the PFS measures were actually pretty good at distinguishing between human and AI responses. They could reliably flag those bots trying to blend in.
So at low levels, it's like those AI cheaters are wearing a big neon sign that says, I'm a BOT.
Pretty much. But here's the thing. As that pollution level increased, meaning more and more AI responses were in the mix, the PFS measures, they started to lose their effectiveness.
Uh-oh. So the more AI cheaters there are, the harder it becomes to catch them.
Yeah, that's what the researchers observed. At those higher levels of pollution, like 25%, the differences between human and AI responses, as measured by the PFS, became less statistically significant.
So this is where things get a little unsettling. If AI is becoming more and more prevalent in education, and let's face it, it probably will, these PFS tools, they might not be enough to guarantee fairness.
Exactly. And it raises those big questions about how we'll have to adapt our approaches to assessment in a future where AI is even more integrated into learning.
We've really gone deep into the weeds here, but let's zoom out for a second. What are the bigger implications of all of this? What does this research tell us about the future of testing and learning in this AI world?
That's the million-dollar question, isn't it? And that's exactly where we'll head next. We'll explore the wider impact of all of this and what it means for the future of education. Stay tuned. Our deep dive isn't over yet.
So we've talked about how researchers are trying to catch these AI cheaters using those statistics, but what really gets me is this idea that AI isn't just some dumb machine cheating. It seems like different AIs actually think differently, which is kind of cool, but also kind of scary.
Yeah, it's like, what does thinking even mean when we're talking about AI? A whole other deep dive there.
We should add that to the list. But for now, let's stick with education. If AI can beat our tests, does that mean we have to just throw out all the tests and start from scratch?
I don't think it has to be that dramatic, but this research definitely makes us rethink how we test knowledge and skills. You know, if AI can just memorize facts and solve those basic problems, maybe those shouldn't be the only things we test.
So test what AI is not good at yet, like critical thinking, creativity, ethical decision-making, collaboration.
Right. All those uniquely human skills that are hard to replicate with algorithms, those are going to be even more important in the future when AI is doing all the routine stuff.
You know, this reminds me of something I read about companies using AI for hiring. They found AI is really good at screening resumes and finding people with the right qualifications, but it's not so good at assessing things like cultural fit or someone's potential for growth.
That's a great point. It shows how AI can be this super powerful tool, but it's not a magic solution. We still need human judgment, especially for those more complex parts of learning and testing.
So where do we go from here? How do we change our schools to focus on these higher level skills?
It's going to take a lot. We have to rethink how we design lessons, develop new kinds of assessments, and train teachers to use AI in the classroom. And probably the biggest thing is helping students learn how to keep learning their whole lives.
Sounds like a big challenge, but also really exciting. We're talking about redesigning education for the AI age.
We are. And yeah, there are going to be challenges, but this research shows us what's possible.
Hmm.
We can create these learning spaces that are more engaging and personalized for each student and get them ready for the future.
So to wrap things up, what's the one big idea you want listeners to think about as they go out into this AI world?
If AI can pass the tests we made, it's time to up our game. We need to create those learning experiences that build those unique human skills. Those are the skills that are going to matter in a future where AI is everywhere.
That's a great point to leave on. So to all our listeners, stay curious, embrace the challenges, and never stop learning. The future of education is up to you. That's all for this deep dive. See you next time.